Okay, everyone. The next problem we're going to solve is this problem where it involves an acceleration expressed in terms of velocity. So this is actually example problem 12/155 in your textbook. So in this problem you have a racetrack. So this is a racetrack. A car is actually going around a circular racetrack. So the race car travels around a circular track with speed of 16 meters per second. Right? So this is the car, this is you in your Ferrari. When it reaches this point A, it increases its speed at at equals to 4/3 v to the quarter, power quarter. Okay? So at this point A, you start to step on the gas pedal, and now the acceleration becomes a function of velocity. Right? As we mentioned before, acceleration usually is a function of velocity because of air resistance and whatnot. Now you have this, and you're asked to calculate what is the velocity at B, acceleration at B, and also how long does it take to go from A to B. Okay? So for this kind of problem, we will first need to figure out what is the general expression for V, and then use that to calculate VB. So we can start from here. AT is equals to 4/3 v to the quarter. Okay. And we know that this is my dv dt, right? 4/3 v to the quarter. So I'm going to move everything to one side, right? All the v term to one side. I'm going to have dv, okay, so v to the quarter is equals to 4/3 t, right, on this side, already know it's t, okay? So if I solve for v, what I get is v is equals to t plus 8 to the power of 4/3. Okay, of course I've omitted some steps, which I think you can do, right? You can do this integration. But from there, I need to do another thing. Okay, I would like to actually calculate what is the expression for the displacement. Right? So I have an expression for V. So from here, I know this is ds dt is equals to t plus 8 to the power of 4/3. Okay, so let's just figure out what is the expression for displacement. So, right, on the left hand side, s is equals to this whole thing integrated, right, from 0 to t. Right? So this is from 0 to t, t plus 8 to the power of 4/3. Okay? Turns out that this is equals to 3/7, okay, t plus 8, right? And this becomes 7/3, okay, from 0 to t. Okay? It is important to evaluate at 0 also because there is a constant term in this expression. Well, you can just say it's 0. And eventually this becomes 3/7 t plus 8, 7/3 minus 54.86, right? Because you have 8 to the power of that times 3/7. Okay, so this is the expression for displacement in terms of time. Okay? So with that, the next thing I need to do is to figure out what is the displacement from A to B. Right? Displacement from A to B. A to B, right? And that will allow me to calculate time, right? Once I know this displacement, I can actually use this equation to calculate what is the time it takes to go from A to B. And then, knowing the time, I will take the time and plug it in here to calculate the velocity. Okay, so the displacement from A to B, right? A to B, what is that? Well, this is 90 degrees, okay? Roll here is 200, so it's 200 times the angle, right? So 90 degrees is pi over 180 times 90 degrees, right? Pi over 2. Okay? So what I have here is 100 pi. Okay? And of course, this is equals to that, right? So it's 3 over 7 t plus 8 to the power of 7 over 3 minus 54.86 is equals to 100 pi. And therefore, now you can use your calculator, or you can go to Wolfram, which is the producer of Mathematica and MATLAB, and use that to evaluate what t is. So if you get your numbers right, t is equal to 10.108 second. Okay? So therefore, v is equals to 10.108. Plug in here, I have 18.108 to the power of 4 over 3, and that gives me the 10.108 plus 8, 4 over 3, and that gives me 47.6 meter per second. Okay, so this is actually your VB, right? This is your VB. Okay, so first part solved. Second part, your A, B is equals to A and B plus ATB squared. Okay. So let's look at AT, right? So ATB is equal to 4 over 3B to the power of 1/4. Okay. At B, we already know that B is 47.6, so we can right away evaluate this. It's 4 over 3, 47.6 1/4, and that gives me, what's that? 3.5 meter per second squared. Okay, and A and B is VB divided by rho B. Okay, so this is VB 47.6 squared divided by rho B is 200. Okay, so that is 11.305. Okay, so therefore total AB is that square plus that square root. So it's 3.5 squared plus 11.305 square root, and that gives 11.8 meter per second squared. That's AB. Okay, so we actually have this 3 answer. This is part C actually. Right? So A, B, and C.